This is supposed to help us, right? This DW one.
Okay, hello everyone. I'm Kyril from CNAR Project, and I'm going to be doing a brief walkthrough of basic coding and services that we need to use. Well, basically the use case is, given a street address, what do I need? What are the services that I need? And what kind of open data do I need before I can get my MP or my representative to show up on a screen to use for an application. So we're going. So, okay, sorry for that pause. So how we're going to do this is that in future, at the end of this, I would actually be making all this into a much easier library. So the purpose of this is mostly to understand what parts are actually needed to build before we can get a simple command, or a simple function that would say something like, this is my street address, and it immediately returns your MP. So this would kind of give the back. You probably won't be writing this code again on your own after we've made it simpler. But so this is just mostly the step-by-step to see exactly what goes on behind the scenes before you get something as simple as just finding out my MP from a street address. So I'm going to switch. First, a little bit word on our sponsors. I'm going to go switch to my screen. We're using components called Populous. So Populous is basically a number of software components. That so that you don't have open source software components for open government or civic tech, in which you don't have to rewrite basic components that you need to build civic tech. For example, you don't some of the services we use will be using Puppet, which provides an API for persons and organizations. So you don't have to rebuild a database and an API for this, and instead just use Populous. It's got a nice interface, basic interface for you to start filling in, for example, House of Representatives, government representatives, organizations, and so on. And yes, so if you're a developer, you should get involved in this. It's a global community. I think there's over 60 countries now. And hundreds of developers, all of us working together, trying to get working on open source components for civic tech. Also, this work would not be available without the support of CIADI. So CNAR Project is funded for the work that we're currently doing. And also, the initial import for our parliamentarians is with the support of a grant from Populous via My Society UK. We also had a generous donation from the electoral candidates from the past 3 years, the past 3 elections, sorry, that we got, which was donated from our friends at Malaysia Kini. So let's get started. I'm going to be using IPython Notebook. This is a really good way in which you can do interactive coding and documentation at the same time. I've actually already written it out in a nicely documented format, which I'll share after this. But for now, I'm actually going to start a new notebook so that we can go through step by step. If you're not a coder, it's okay, or if you haven't set it up. But mostly this is to be able. But if you are, you can follow along and try typing by creating a new notebook. So let's start. So one of the first services that we use is basically called a geocoder. A geocoder basically is a service that gives you the latitude and longitude format, often pronounced as just lat long, given an input of a street address. Or even it can be a place name or a business name, depending on what type of geocoder it is. Okay, so what does a geocoder do? I've just shared that it provides a service. So given a street name, a street name by itself is not very useful because you don't know where it is on a map. In order for it to be shown on a map, the computer needs the coordinates. So a geocoding service will take the street name and it's going to convert the street name into a lat long address. So there's several geocoder services available. The two main ones that most people use are Google. There's also OpenStreetMaps. There's also Bing, and there's a couple of and a few more lesser-known geocoding services. You can actually combine all three to get more accurate results if one of them fails. But for the purpose of this exercise, we're just going to use the Google geocoder, mostly because for Malaysian addresses, it's one of the most complete one. So we're going to be using a Python library called GeoPy. Which provides a simpler interface for geocoding. And we're going to use Google's latest geocoding service. And we're going to use a street address. This is our office here at Senior Project. Okay, so for the purposes for commercial services such as Google or Bing, you usually need an API key. You can get your own key for Google Maps for your own usage at this address, or you can just Google for Google API keys. And where you would generate a key through the console, we're not going to go through it here, where you would generate a key and you would enable the geocoding service API to be able to do this. So I've actually set up my own key. This is my key. It's not going to work if you cut and paste this because it's limited by IP address. And so I'm going to set up my geocoder. Google v3 and API key. Okay, so this sets up the geocoder. So using this geocoder function from Google Maps, we're going to try find out what is the latitude and longitude of the street address. So geocode. And our street address that we filled in. So I'm going to run this through. And if I get the geocode right now, I should get a left and long coordinate by default. So if you can notice, so I've got a location. So on the map, this is 3038123101584. So if you actually put this in Google Maps, it would actually give me the coordinates of exactly where I am for that street address. So let's actually try it out. So let's pick a place. You notice that when I pick a place, you see the coordinates at the top. This is exactly the same thing as the geocoordinates that I've got from here. So if I actually cut and paste this into Google Maps, it would actually pinpoint exactly where I am. So as you can see, using this coordinate there, it's pretty close to where the CNR project office is. So that gives me the point. So a geocoding service basically has given a street address or a business name, can give me exactly the point that I am on a map, as close as possible. Depending on the accuracy of your street address, if I added additional number, for example, it might be closer and more accurate in terms of office number or office block. But basically, that's pretty good, accurate enough for our purposes. As you can see, I'm probably about 100 meters off. But having just this point is not very helpful. The problem for it is that, well, it just gives me a point. It doesn't say much. If you look at the code, if I'm not mistaken, using geocode and address, it might give us a little bit more information, such that I'm in the suburb of Subang Jaya, and I'm in the state of Selangor, and I'm in Malaysia. So town, state, and country. But that doesn't really tell me anything much about my electoral boundaries, exactly where, which parliamentary constituency I am. It doesn't tell this. This is where we start using another service called Mapit. Mapit is actually a Populous component where if you insert data of map data or so-called shape files on boundary files, given a particular point, such as we've got from this geocode, it will return the boundaries that our little point is. It can be, for example, as simple as a state boundary. It could be a local council boundary, or it could even be, in our case, what we want to find out is a parliamentary constituency boundary. So this sort of data is needed first. So you need these shape files or this boundary map data. That you need this first before you're even able to find out where your parliamentary constituency is. Luckily for us here at CNR Project, we have a local NGO that's doing electoral delineation work, and as part of their work, they've actually digitized all the different boundaries of all the electoral boundaries, which include parliamentary, state, as well as voting areas, which they've shared with us, and we've imported into the Mapit service. And because of their work, we're now actually able to look up what electoral boundaries we are in given a specific point. So our next step here now is the Mapit service. One peculiar thing about the Mapit service is that it actually takes the geocode in reverse format. So I'm actually going to reverse the geocode. In this little Python script. So basically what I've taken is this, given the first tuple here, I said flip it around. So I think that syntax is correct. So if we actually tested out what the reverse geocode looks like, it's now in 101.303. It's just how the Mapit service takes it. It's the same code, it's just reversed the other way around. So one of the things that most modern web services use now is that they use the JSON, they use a RESTful API. A REST API basically works in a similar way as you actually entering data. So basically, this makes it really easy for developers because you can actually test the results just by putting URLs in the web page. So the Mapit service here, I will just quickly show you. It's like a web page. It does have some examples on what kind. So a REST API request is basically a URL. It can be a post or a GET. In our case, since we're doing read-only, we're just doing GET. So it's really easy to test. You don't need to code or anything just to test to see if you can get information out. So the module for this that makes it easy is the request module in Python. So I'm going to put requests. So this is basically a little module that makes HTTP requests. The other one is that we probably want to import JSON library module from Python, and this is the standard format that we usually get from API. It's in the dictionary format, and I'll show shortly how it looks like. So the next step here is that let's get all the parliamentary areas in Malaysia. So the URL to do this, close a few of these tabs. Okay, sure. So I can actually just type this out. /area/par. So this is how a JSON format data looks like. It's called a dictionary type, where you would have it in little brackets, the ID and the value, ID and value. So in here, I think we have about 33. I'm not going to scroll through all of them, but basically we have all these different parliamentary codes: P0141, P104. Hello, we've got a comment here. Sorry, I can't hear clearly. Sorry, Harsh, I can't hear your question clearly. Can you? Okay, sorry about that. Noise. Somebody has made a comment saying, please increase your font. Okay, I will do so. Michael had a comment on how did I get the autocomplete. This is actually a feature of IPython. IPython provides all the autocomplete features of modules as well as traceback. Okay, so I've got import requests, I've got import JSON. So as I said, this is how a request looks like. A REST, it's just a URL. So you can actually debug it in your browser to see whether you're going to get the values or not. There's something interesting here in terms of the open data. If you notice here for 7207, which is the one that we're going to be using, it's complete. It has Kendalana Jaya, it has Parliament, it's got Malaysia. But if we scroll down a little bit lower, we'll notice that at 7128, we only have P0141, for example, and without the names. So in our data, in order to get all the names, we're actually going to have to enter. So our data here isn't complete for parliamentary in terms of names. So we're actually going to have to go back and start filling out all the different names for all the parliamentary sites. But the good thing is that we only have to do this once, and because it's open data, in future when we clean it up, everybody will be able to get the full complete name codes for all these different electoral boundaries from the Mapit service. So we're gonna go back. So that's import JSON. So now we're gonna make we're gonna do the same request that we just did in our browser in code. So ours, which are our parliamentaries, equals request get HTTP. We can actually just even copy from the same URL. It's the same thing. And if we actually did the content of it, oops, I did it's requests. Oops, it's request.get. Okay, so this is what I get in the content. That's not very pretty because basically what that has just dumped through is just basically the text that we get from the request from the website. So to make it more useful in code, we're going to convert this into a JSON format. Which the module does nicely. So parse, all this parse, JSON. Okay, so somebody actually said that I can actually do it a lot quicker by just doing parse. But I'll do it in my code for now. So using this one, I print out parse.json. We'll actually see it's now in a much nicer format that's easily readable by Python. So this is all of our different, all of our Parliament areas that we have in our database right now. Which we're going to be using later. So what we've all got just now is we now know all the different IDs of all the different parliamentary boundaries that we have in our database. But we still haven't actually gotten which parliamentary boundary that we're in yet. So as you've seen before, we know our location. So our location is basically using the Mapit interface in reverse format. This is how it looks like. And if we remember our code just now with our location, it's in this format. So it's 3101, it's reversed. So in machine language, this is basically if we make a request with our coordinates, we know that we're in Kelana Jaya. You know this is. The Mapit interface also provides a we're also in Daerah Mengundi SS16 and SS17. We're in Subang Jaya Zone 1 of a local council. We're in MPSJ. And we're in Dun N31, which is the state thing. So these are all from all the different boundaries that we have in the Mapit. The one that we are of interest is Kelana Jaya, which is the parliamentary. See, if you look at here, it's type name parliament. We also have PAR. For a nicer view, you can actually have .html. The Mapit service provides a nice view of a more human-readable, viewable content. If you put .html. So I'm in Parliament Kelana Jaya. I'm in Malaysia, obviously. I'm in the state seat of N31. I'm in a local council of Subang Jaya. I'm in the state of Selangor. And if I was going to be a voter, I would be voting in an area called SS16 and SS17. And I'm also even a subzone of my local council called Subang Jaya Zone 1. So these are all the information that I know in terms of. So what's useful about this? Well, I could know, for example, who my parliamentarian is. So I know that I can look at my MP, who's the MP for Kelana Jaya. From this data, from this point, I know that I'm also in the area of N31. And so I can actually, if I have the open data for it, I can look up who's my state representative for N31. And if I was going to build a local council reporting problem, I could say that I would actually I can actually look up and see who's my MP, who's my representative for Subang Jaya Zone 1. Actually, we can even do a Google search right now of that. Local councillor. Zone 1, Subang Jaya. So that information is not readily available. Let's see if you can look at here. Let me just make the fonts a little bit bigger. You'll notice that from our point, we know that Mapit has said that we're in Zone 1 in Subang Jaya. So this is our local councillor. And N31 Subang Jaya, that's our representative for this dot. So you can see who's responsible for us in this area. I'll go back to my code. So let's make that request then. Location. Let's make it a little bit more automated. First geocode. We just want the first tuple like we did before. Seven values. And we're going to make that request. So let's try this content app, and let's see if we can get the posts as we see. Post 404. Oops, I'm in a problem here. Reverse picture. So one map it as project. Looks like I have a little typo in my geocode. Okay. Oops, yep. Thanks, Motion Man, who's following, that I forgot a space. The URL actually has a space, try 20 here. So, try that again. Oops, that looks like you still have a space there. Location. Try that again. And errors.url. Oops. That's my mistake over there. Sorry. I actually added an additional space under the S here. Let's try this again, and this should fix the problem. Okay, so now I've got a valid URL. So if you get a request right now for errors, it's at 200. And if we actually have the content, again, we have this pretty boring code, and we're going to load this up as JSON. Okay, so now we've got the codes for all of our different areas, except we're only interested in the parliamentary code. So earlier on, in this code, as I've shown, we actually pulled in all the different parliamentary sets, so we can actually just find out which one is the matching set this time. Am I doing? Hold on a second. I use areas or area? JSON. Hold on a second for this. I've got some. Okay. Oops. Typo, sorry. Method. Okay. So basically what we've done here, what I've just done here is that we have all the different areas that we've listed here, but we also have also a list of Parliament areas. So we're only concerned about the area that's a parliamentary area. So what I've done here is I've basically created a set, and which area matches that of a parliamentary area, and we get that code here, which is 7207, which is the specific ID. So now we have the ID of the Parliament area. We can now start getting information in Python about our constituency. So constituency. Can't spell. I'm just going to use consti. So consti. Let's see if we can get a name out of it. All right, consti. So here it is. So what we've basically done is, initially we got a list of the parliamentary constituencies. Then, given a location, using the Mapit service, we've got a whole lot of different types of boundary data, local council, state, and so on. And what I've done in code number 24, line 24, was basically say, okay, we're only interested in the parliamentary area. So give me the ID just for the parliamentary area, which is 7207. And earlier, when we did the listing of all the parliamentary lists, we actually have all the different codes in parse.json. So we basically just want the specific code of 7207, and that would give us the information for the specific constituency that we have. So here, as you can see, we've now got all the data that we need. So given a street address, we've used, to sum it up, given a street address that we know, we've used a geocode service called Google, using Google, which then gave us a point, a geocode, or a location, 307, and then we pass this code to the Mapit service, which is this location code, and that in turn gave us all the boundaries or administrative boundaries that it knows for that this particular point is in, Malaysia, state, Dun, and so on. But we were only interested in the area of parliamentary areas, so we did a set, and we said, okay, just return only the ID for parliamentary area, which is 7207, and then we looked it up again from that list of parliamentary codes, and now we've got our parliamentary code, Kalanajaya. So we need a geocode service, which helps translate the name to a lat long. We then need a Mapit service, which provides us boundaries given a point, and the boundaries that the Mapit provides is a list of maps that have been digitized into shape files, which have to be imported into Mapit before we can even get any of these electoral boundaries. So while the code is all complicated, the basic things, summary for open data is that you need a good geocoder service to be able to accurately get a coordinate from different names. It could be buildings, it could be names of businesses, it could be street names. So the better your geocoder is, or if you have multiple geocoders, the more accurate your location is. And then after that, the more boundaries that you have, the more information you can get about where you are in terms of the context of your particular point. Which state am I in? Which parliamentary constituency am I in? And only when you have all of those open data in place would you actually be able to run commands like this to be able to get which parliamentary area you're in. So somebody actually had to digitize this. So in our case, Tindat Malaysia has done this work and have thankfully donated it for use by everybody else. So before we even get to find out who our next MP is, already at this stage, there's all sorts of possibilities. So given, for example, if you're working in open data, let's just say you have a list of all the schools and with the street address of all the schools in Malaysia. Looking up the geocode for each of the street addresses of these schools, you can, and then using the Mapit service for all the geocodes, you can now quickly get a set of information, for example, how many schools are in, say, the state of Selangor, or how many schools are in the parliamentary constituency of Kelana Jaya. So just from having the street address of some sort of data from somewhere else, you can now actually work on this. So yeah, the possibilities are huge. We will be working on, CNR project will do some examples with construction contracts, so that we'll be able to see, for example, how much things were built in specific constituencies, because our government usually promises, such and such development will happen in such and such constituency under a political party. So with the shape files of the parliamentary constituency, the Mapit service, and the geocode service from Google, we can now actually put it all together to find out, how much development was actually done in specific electoral constituencies by parliament and by state. So the last step now is I'm actually going to use another puppet. So we know our parliamentary area now. So the next thing is like, who's our MP? Well, one way you can actually do that, of course, if you do it manually, is that you can actually Google for it. So we go Kelana Jaya MP. And you'll notice that it'll return P04 for question. Of course, this is the human way of getting it. But if you need to do it in a programmatic way, you're going to need an open database of this. So you're going to need the names of people, of all our parliamentarians, and each one of these parliamentarians are going to have to also be assigned to an area code, such as P104, so that we can actually look this up automatically in our programming code. So let's say, please give me who my MP is. We will need to do the geocode. We would then need to look up our parliamentary constituency, thankfully with the Mapit service and the data from Tindat Malaysia. And finally, we will need to have another database to look up and saying for P104, another service that provides persons of interest for P104 area, which in this case should be who the MPs are. So CNR project has been building up a huge database of this, of persons and organizations, our parliamentarians, our state representatives, politicians, board of directors of GLCs, and so on, so that we can actually have a database of persons or organizations to actually look up to. And the good thing for us is that we've mostly done most of the parliamentarians right now. So this is a different interface now. It's another service called Puppet, and It's at cnar-malaysia-puppet.mysociety.org, and this is an entire database with the same kind of API in JSON that you can use to look up and search for people and organizations. So I'm going to go back to my little notebook. Let's just call this Puppet. So we would do the similar process as before. So let's search for posts. And here post means somebody holding the post of MP. Let's see. Yeah. This person for P04. So here's the query, and we're going to look for P104. And as I mentioned before, you can actually, oops, not P, that's going to be a syntax error. If we actually do this now and we try out this little search on our browser, it will return to us people holding the posts for parliamentary P104. This is not very user-friendly, but you can see this is the data side. You'll see that there's an MP for Kelana Jaya. How many results did it have? It got one person here, and it's got another person here. So there's 2 members of parliament. If we actually browse through it, into the House of Representatives. So this is the human viewable version, and we look at who's holding the posts for Kelana Jaya. We would have 2 people who are and have held the posts of Kelana Jaya. So in our database, for example, we know that Wong Chen has been the member of parliament for Kelana Jaya since 2013, and we have another person here, Loh Seng Kok, who was the MP from 2004 and 2008. So this person was so the second person is not the current MP. But if we wanted to search for example, by 2004, 2008, we would know who the MP was at that time. I think we're missing the previous data, which is, I think his name is Gwei Le Byrne, I think, which was the MP before Wong Chen from the period 2008 to 2013. So that's an example of gaps that we're missing that we need to fill up so that it's useful for everyone else. So it's a massive effort. I think we have about 4,000 people so far in terms of the last candidates from the last 3 elections, and that's not necessarily complete either, or accurate. So it's a lot of effort to clean all this up. But once we've cleaned it up, you now can use it. So let's do this in computer format. So post, so that's going to get us all the MPs. And we're going to get this in a JSON format. Okay, so this is some additional things. Need to be able to do some date range checks. This is actually because there's a bug in the Elasticsearch in the Puppet database. Ideally, we should have just been here, but since it doesn't, we're going to have to manually do it in Python. And let's click use the start date of the last elections, 2013. I think it was May 17th, something like that. Oops. Start date. Okay, that one gives a bug. Okay, that looks alright. So we now have the date and state time, members, JSON, which is the results. Memberships. So right now, if we actually tried out our members, this is the JSON. So we have the two people. We've got one guy here and another guy here, but we don't know who they are yet. And of course, we have the start date. So we're going to use, let's write a simple function to do some comparisons. Yeah. Doesn't work for it. Okay, just to explain a little bit of this little function that I do, which hopefully won't return a text error. So basically, we know that JSON has two different members, and they have different start dates, and there's an ID of who that person is. So what we've done is just basically use the dates and compare it. So if it's more than the start date of 2013, which is the last general elections, then that's probably the right person. So, and anybody before that would probably would not be the current elected member anymore. So, that's the kind. So, yep, we should be able to get our current rep. So yeah, as it's expected, we got one ID, which is in Puppet. And now we need to do another search on the API to get the details of who this person is. Let's cross. API search. Except we're going to look for a person. And the Q is the ID, which is what we got here. As before, we should be able to test this because it's just a RESTful API. Did we get somebody? Yes, we got one person here. So let's see, who is this guy? It's Klanajaya. The guy's name is Wang Chen, so that looks about right. We have some other information about him, such as his email. We even have his little his website. It looks like it, and also his picture. So oops, that's all right. I think it should be the first ID. Let's see if we got it right. Oops. Let's look at my traceback. MP-JSON. Equals. Oh, yep. So now we've got all the IP addresses that we want from the person. So from here we can see we have names. We can even look up, for example, what political parties that he has, like for example, what organizations that he's involved in. But for now, let's just quickly use some things that we can use. So MP name. MP. Right, let's look up. This. Should be some contact details in here. Contact details, there it is. We have the value of contact details type. Okay. Value. Okay, so the key for this value. And we can get his email address, for example. That's another thing that we can have. Maybe one his picture as well. Do we have a picture of him? There's images there. So we actually have a picture of him. Let's just copy this. And let's print this out so we know who they are. Okay, so we got Wang Chen, who is the MP for this little area, for the street. We've got his email address, so you can now have a lookup for who your contact of your MP is. And let's use Markdown to get the picture, so we can display it here. See how he looks like. Oops, I think my syntax is wrong. Okay, it's a pretty big picture, but who's our good-looking MP for Jalan? Yay, we finally reached the end. Okay, So one of the cool things about IPython, which I've used, is that I can actually save this, and I can actually share this notebook so that you can actually load this file as a notebook. I'll type in the URL shortly, so where you can get it on GitHub. Project. Project and reps, and under the docs there is a Malaysian notebook, so you can actually download this or you can check it out, and you'll be able to have the notes for my notebook that I've used. So hopefully that's readable. So it's cnr.myreps is the repository. Okay, so in summary, I'm just going to go back through what we've just done. So again, this is just a concept. You need a geocoder service. The geocoder converts a string such as a street name or business name into a location or geocode. You then need this geocode to submit to the Mapit service, and the Mapit service will, if you put in a geocode for a Mapit service, will then return you a codes for this specific location of all the administrative boundaries that it has in the database, which we have the parliamentary area. So from that, we can get the parliamentary area from the Mapit service. And once we got the information on the parliamentary area, such as the code, we can, or even the name, Kelana Jaya, we can then use the Puppet database to search for who's holding this post as an MP for P104. And we can do things like find out who's the current MP, so we can have a list of current MPs. And if we're building a website, we can then get things like their details, such as who their name is, and even a picture if it's accessible, website URL, and so on, depending political parties if we have it. So right now, I think for most of our, we've got most of the politicians in the political parties that they hold, and most of the MPs, and we haven't had the Adun reps are in our Puppet database, but we haven't filled it in, I think, for all the different states accurately yet. So this is the amount of work that you need. So it looks simple. Let's just get a geocode. Let's look up a Mapit service. Let's get the parliamentary thing, and then we can get the MP. But each one of these steps requires a lot of open data, either localities for the geocode to work correctly, the boundaries, so that we know all the different boundaries, local councils and whatnot. And then after that, you need open data on all the different people and posts that they hold, matched to the areas of the boundaries that we have, so that we can actually look up who's responsible. We also need their start and end date of when they hold their posts, so that you can get the actual persons accountable for a specific electoral area. There's all sorts of possibilities for this. We just worked through the case. There's, for example, I gave earlier in the introduction, now that you can take out electoral boundaries. For example, Transparency International, they have a site called Forest Watch with all the geolocation codes. So we've gone through this, and we now know that we can actually get the electoral boundaries of which political constituencies actually these deforest, illegal logging has happened. And even better, if we have the date and the time, we can actually find out with the Puppet service to find out actually who the MPs are and which constituencies, for example, would have the most illegal cases of illegal logging reported. Number of schools, dengue cases, as long as you have the address, you should be able to now look up. You should be able to, as a developer, easily look it up. And just before I wrap it up, as I said, I have shared this notebook here on GitHub. It's at cnar/cnar-migrants on GitHub, and there's a notebook that you can check out to load in your own IPython to try out on your own. So all the code that I wrote here, plus some additional explanations are there. And the other part is that it's a lot of code that we've written today. We're going to actually make it even simpler so that you can just, we actually just have a library where you just put a street address and it'll all do it nicely for you. But it's important for this session actually to know what work goes behind this before you can actually get something as simple as give me my MP for a given street address. So thank you for joining me. I'm just going to see if there's any questions from the people following the Hangout. Okay. We had a comment. There's no questions other than a comment on the photos. But okay, so that wraps up for this. If you have any comments or questions, if you're following this on YouTube, just leave a comment on our YouTube channel or our Google Plus Hangout. And we hope to do more of this, or do leave us some suggestions on what you'd like to cover in terms of what you've learned today for future sessions. Okay, thank you. Bye.